doing well and we can hear you. You have 10 minutes. Good luck.
Please start, please.
Okay, so like myself, Dr. Tina from Alliance University, India. Like I would like to present before you the paper titled SIEFC, a hybrid swarm intelligence framework for fuzzy clustering of high dimensional healthcare data. So like this is the outline, like introduction, motivation, proposed methodology, results analysis, and conclusions and references. So in today's world, like we have got a tremendous lot amount of data where healthcare data is too much, and like they have got like in gene expressions and all, we have huge amount of data. So like these challenges which we include in high dimensional data is curse of dimensionality, then there will be noise and outliers, overlapping clusters. So we need to improve these clustering techniques. So with this motivation, like we have tried to develop a hybrid clustering techniques based on fuzzy C means, where we are integrating a hybrid one with respect to the particle swarm optimization and artificial bee colony, those two algorithms, we are trying to make it a hybridized one, and then we are trying to solve this issue of like high dimensional data. So we do this with the help of this adaptive feature engineering, and so that we are demonstrating it with a healthcare data set. So this is a proposed methodology where we have got the high dimensional healthcare data set, where we are first doing some pre-processing techniques, and then we are doing the SIEFC framework, where we are integrating the particle swarm optimization as well as the artificial bee colony optimization. Both are like integrated, and then knowledge transfer is happening, and then those optimization is being taken, and then we are doing a clustering technique, so that we are grouping it into the clustering outputs. So this is a general framework proposed methodology. And we have evaluated in the WDBC dataset, which is a breast cancer dataset, which have got the 569 samples with 30 morphological features. So we have taken the evaluation parameters like short index, and internal validation metrics includes like there is no ground truth in it. So we have compared the proposed algorithm with the PSO, then ABC, then kernel-based fuzzy C means, and the normal fuzzy means. Where for all these performance measures, the proposed methodology have shown the comparable performance. You can see it is like in all the cases, it has shown improved performance. Now coming to the external validation metrics, where there is a comparison with the ground truth. In that case also, when we are comparing it with, so we have taken the performance measures like adjusted rand index, NMI, and accuracy. In that case also, the proposed have shown a comparable performance when compared with the existing techniques. So now when we are plotting the box plot of the adjusted RAND index for various clustering algorithms, in for that also, like we can see that in the proposed one, it is not overlapping with any of the other proposed techniques, and it is showing a band of 0.85 to 0.87. So it is in a different band, so showing its performance. Now coming to the confusion matrix plot also, like when it is trying to classify between benign and malignant, the accuracy, the overall accuracy also, it has been shown with 94.87%. Now coming to the feature importance analysis, like how well the by doing the feature weighting and all, how well the features have been captured. So by taking into consideration there are many features, it has we have sorted it out of the top 10 features, where the weighted importance weight is also calculated. So all the features which we have considered is also showing that is of importance, and which has been considered the features for the clustering part. Now, coming to the clustering results, this is a PCA visualization. The first one is a ground truth, like actually how it has to be with the ground truth. Now, the second B figure is with the proposed method. So, by comparing these two graphs itself, we can show that almost all the cases the clustering have done in a proper way. Only for very few case it has been overlapped. Rest of the cases like it has been done as it is in the ground truth. So we can say that it has shown a good results when the clustering is also taken into consideration. Now, coming to the TSNE visualization also, it has got the three different visualization of the ground truth, SIEFC clustering results, and the membership degree visualization is also shown. So, comparing with the ground truth and the SIFC result, we can see that almost similar to the ground truth, the proposed have performed. Now, coming to the membership functions, for all these clustering, the membership function also have shown that it is almost giving the comparable results when we are visualizing with the membership degree visualization. Now, coming to the convergence analysis, like how well the framework is converging fastly. So, like we have compared with the fuzzy C means, PSO and fuzzy C means, ABC and fuzzy C means, and SIFC. When comparing with all those things, like the red one is the proposed one, which is showing like faster convergence when compared with the other techniques. Now coming to the the stability analysis also, when compared with the other facility means clustering, the proposed SIFC have shown the stability analysis with this violin plots also. We can see that compared with the other plots, it is showing a good performance with the point 8 to 2.91. It is in the a different band where there is no overlapping and all. So now when we are considering with the parameter sensitivity and the computational efficiency, so these are the three figures which shows the effect of the fuzzy exponent, then the effect of the population size and the effect of the knowledge transfer. So when coming to the fuzzy component, we can see that uh, it has been growing since like 1.25 to 2, and then from there it has started to show a decrease. So the major improvement is happening from 1.5 to 2 in that region. Now coming to the population size also, as populations is increasing, the ARIs also has been increasing, but there is a slight variation. When the population has reached about 60, it has decreased, and then it has shown the increase. Now coming to the knowledge transfer, the knowledge transfer also we can see that it has increased, like gradually increasing in the training time, and then it has decreased. So the knowledge transfer also shows that it has been almost the transfer in the all the knowledge which has from the PSO and the ABC. Now coming to the computational efficiency comparison, the SIEFC have taken a larger time when compared to the other techniques, but still, even if it is taking execution time more, it has shown a good results like when compared to the existing techniques. So even if it has taken long time, the better results give the better accuracy and efficiency of the model. So coming to the conclusion part, like we have developed this SIEFC framework, which have improved the clustering accuracy, the stability, and interpretability of the model by combining the features of the particle sum optimization and artificial bee colony. So it has given a clinical meaningful healthcare data. It has to cluster the high dimensional data. It has been taken. Now coming to the future work, it can be applied to the other healthcare data sets, and also deep learning framework can also be integrated into it, and further like computational optimization for bigger data sets can also be considered as a future aspect. Now these are the references, and it's open for any queries. Thank you.
From the output run through Python programming.
Yes.
Okay.
Many thanks for your great presentation. Okay, now all dear participants, if you have any question, you can raise your hand.
Tina madam, will you present the
Yes,
next
sir.
slide, please?
Yes,
Please.
sir. Yes, sir.
I think you and the Rekha Nair ma'am same university, no? Alliance University.
Yes, 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 sir.
Yes. Okay, madam, please.
Okay. So this is a second paper, that is a shadowed sets for feature selection in high dimensional biomedical data analysis. So here, like these are the outline and like the introduction, like why we need shadowed feature set. Like here also we are considering about the large data set which is available in the like healthcare or biomedical data, where here also there is like curse of dimensionality. So what we are doing here is we are applying like a clustering like a fuzzy sets for the shadowed feature set. So like we are comparing it like the current the existing techniques like PCA, MRMR, relief fuzzy set. So to
Madam,
over,
share the
yes,
slide.
it is not shared, sir.
Yeah, it's not visible.
Sorry, sir. Sorry, sir. I thought it is shared.
Florian, please help to.
Is it
Yeah,
visible right now?
Okay.
oh,
Okay.
that's your
Okay, madam.
screen. Okay, thank you.
Okay. Fine. So like in traditional approaches, we are using like PCA, relief, MRMR fuzzy set, which is like difficulty in handling the uncertainty, the complexity, and the lack of biological interpretability. So like there are problems in the existing techniques like limited effectiveness of the unseen data. Like I have mentioned about the handling of the uncertainty. So we have come to the proposed methodology where we are using the shadowed set. So what is the advantage of shadowed set is that it will be identifying the features which are like more relevant. So we are dividing it into three regions like inclusion, exclusion, and the shadowed region. So inclusion means that features have definitely to be there, and exclusion means which are like noise and which are not relevant to the model, and shadowed features are like which is like only like it is required but not of that importance. So in order to identify these things, we have applied the shadowed set code. So by this the feature selection will be done, and then the performance evaluation is also
Can you
performed.
show the output?
So
Output.
yes sir, yes sir. So this is a data set where we have applied. Now coming to the feature reduction ratio and the number of features selected, we can see that the proposed have got the feature reduction ratio more, as well as the number of features which has been selected by the proposed is the lowest one. Now, when we are comparing it with the accuracy with the different models like random forest, neural network, XGBoost, and then average, when we are considering, the proposed have shown the considerable performance in all the classifiers when compared with the PC and all. Now, when we are
I think
comparing
this
the,
also output
pardon?
database Python programming, correct, madam?
Yes, yes, yes. And now this is with the ROC curve. Here also the classification arrows, it has shown a better performance. Now this is a shadow threshold analysis. So like when we are analyzing the accuracy and F1 score with different alpha beta configuration, because this alpha beta values are the one which defines the three regions of shadowed, exclusion, and inclusion region. So we can see that highest performance have been obtained when alpha is equal to 0.3 and 0.8. We have analyzed with different values and we have found out this is the optimum value. Now coming to the biological relevance, like we have selected many features with the proposed model. Now when we are analyzing the selected features with the proposed model, that also have shown the biological relevance. So these are the top features which we have selected, and it is also known for their biological relevance also, because these are important in identifying the breast cancer. That also we have analyzed. Now coming to the shadowed region analysis, like we can see that the red part is the inclusion region, which indicates that those features are required, those features, and like exclusion region is also like compared to the inclusion, exclusion is less, but still there are many areas which many features which can be excluded, and the one which is in between point 0.3 and point 0.8 as the shadowed region. Okay, so when we are finding out the number of genes, we can see that inclusion there are like only one, one, whereas many genes can be excluded as well, because there are the genes is like some 14,000 genes we have analyzed. So in that, these many have been classified into exclusion, inclusion, and the shadowed region. Now coming to the 3D view analysis, we can see that inclusion, it is like very few, many things can be excluded, and the shadowed region can also be considered. Okay. Now coming to the computational efficiency and stability, execution time, it is taking a little bit more execution time when compared with others, but the results and the accuracy part is shown, like the model, the proposed is showing the good accuracy. Now coming to the stability analysis also, the proposed is showing a good stability analysis before when compared with the other existing techniques. Now cross data set validation also we have tried out. We have tried it with the NK1295 data set, in which we have trained it with the like mentioned data set and tested it with this NK1295. So there also we have we have got like 92.6 as a training accuracy and 89.8 as a validation accuracy. Now with deep learning models also, we have just compared. So with order, like the features selected were like less for the proposed, where the accuracy and F1 score have shown an improvement when compared with the autoencoder and the variational encoder. Now coming to the conclusion, so like we have proposed the SSFA method, which make use of the shadowed set to find out the feature relevance, so that the important features are being selected when there is a large data set, and it effectively balances the uncertainty and the feature reduction, and then the accuracy and the biological relevance were also considered. So when comparing with all the state of the art techniques, the proposed have shown like a good performance over the other. Now coming to the future work, it can be extended to other clinical applications and other medical data, and it can be also like extended by like integrating it with hybrid or deep learning models for the improved interpretability. So these are the references, and it's open for any queries.
Yeah, good presentation, madam.
Thank you, sir.